Lesson 5.1 on the polygon sum conjecture. Now, to do a quick review, from the last chapter, we discussed the triangle sum conjecture. And the triangle sum conjecture said that given any triangle, the sum of the measures of the angles of that triangle equals 180 degrees. Now, this is going to play a very important part in today's lesson. But to get there, we need to do a little bit of deductive reasoning. Let's say we were given this polygon here, quadrilateral ABCD, and we were asked to divide it into triangles so that every triangle's vertex was still a vertex of the quadrilateral. We can divide this quadrilateral into two triangles just by dividing that quadrilateral in half. Now, what's important about that step is that when we divide this quadrilateral into two triangles, we know that the sum of the measures of the angles in each triangle has to be 180 degrees. So labeling each of those 6 angles there, we know that angles 1, 2, and 3 together must add up to 180 degrees, and the sum of angles 4, 5, and 6 also have to add up to 180 degrees. So altogether, what is the sum of the measures of all the angles in the quadrilateral? In this case, 2 triangles. Each triangle adds up to 180 degrees. Altogether, 360 degrees. So that leads us to 2 important conclusions in today's lesson. The first is the quadrilateral sum conjecture, which says that the sum of the measures of the angles in any quadrilateral has to equal 360 degrees. Now, how about any polygon? So far we've discussed the triangle sum conjecture for a triangle and the quadrilateral sum conjecture now for a quadrilateral. But rather than coming up with conjecture after conjecture for every different polygon, can we summarize this property for any polygon? Well, let's try and find a pattern here. Let's look at this polygon, for example. Notice that there's actually 1, 2, 3, 4, 5, 6 sides. So it's a hexagon, 6-sided polygon. And we could actually divide it up into 4 different triangles. 1, 2, 3, 4. So just like the previous exercise with that quadrilateral where we could divide it up into 2 triangles, this hexagon we could divide up into 4 triangles. Now take a look at that relationship there between the number of sides that a polygon has and the number of triangles that it can be divvied up into. What's the relationship? 4-sided figure, 2 triangles. 6-sided figure, 4 triangles. And also that triangle that we had before, 3-sided figure, only 1 triangle. And the relationship is, however many sides there are to the polygon, just subtract 2 to get that number of triangles. And that's how it leads us to the polygon sum conjecture. The polygon sum conjecture says that given an n-sided polygon, the sum of the measures of the angles of that polygon is equal to 180 degrees times the number of sides in a polygon minus 2. So for example, that hexagon can be divided into 4 triangles. 6 minus 2 is 4. Multiply the sum of the angles of each triangle together, 180 degrees per triangle, 4 triangles. It leads us to conclude that the sum of the measures of a hexagon is 720 degrees. But that conjecture applies to any polygon, not just a hexagon or a quadrilateral or a triangle. Thus concludes today's lesson.